Okay, again, for those of you, I see we got a bunch of people joining us here. I'll just repeat myself again. We got on the phone with us Dr. James Neale, the Energy Research Group out of New Zealand at the university there, and a good friend, I might add, as well, to UE Systems and to Gary Moore. We really appreciate having you here today, James, getting up so bright and early in the morning and taking your time to do that. Today, what we're going to be talking about is building a successful compressed air management program. For those of you who have been in previous ones, we've gone through how to do a survey. This one's a little bit different. A little bit about UE Systems. We were founded back in 1973, so we've got like 35 years plus of this experience in ultrasonic technology. We've got people all over the world, 13 of them in direct offices and a bunch of independent agents and a bunch of really good supporters like James out there. So enough about us. What I want to do is welcome Dr. James all the way from New Zealand to come online with us and see what he has for us today. With that, James, what I'm going to do here is I'm going to change this over to you. And once you see that, you're going to actually have control of the screen. So tell me when you have it, James, and then you are ready to begin.
Okay, I believe I have it. Hopefully everybody can hear me. It's great to be here. It's a beautiful spring morning here in New Zealand. Thank you for tuning in. What we're going to talk about today is how to build a successful leak management program. And obviously many of you may have already tuned into some previous webinars on compressed air leak surveys. We're going to focus more on how to actually build a successful leak management program. So the preparation and the post-survey work that we need to do to ensure that we lock in energy saving opportunities for the long term. So what we're going to do to start with is we're going to talk a little about the pre-survey planning. And you know, the phrase that's often almost a cliche now, but is still very true: if you fail to plan, you plan to fail. So what we're going to do to start off with is we're going to talk about a few things that we need to do before we start out on our leak survey. And as with all of these things, working in a facility or plant somewhere, safety comes first. There's a number of initial safety considerations that we need to think about. First thing is obviously the job safety analysis and plant walkthrough to identify the problems or hazards that we need to be aware of when we are doing a leak survey. We need to complete the required work permits, ensure we've got all the personal protective equipment, and perhaps the most important aspects is identifying any specific site or area hazards, special access requirements, working at heights, confined space access, restricted access, and so on. Now, it may seem a little unusual, but as a really good example here, one of the challenges you face as you do your leak survey is you have the headphones on your head. And that means that you often can't hear a lot of what's going on around you. And so one of the things we recommend to people when they do a leak survey is they actually have two people do the survey, not just one individual. So you've got the person doing the survey and then a buddy, if you like, to assist with recording and fixing what can be done on the fly. But perhaps most important, someone to watch the guy's back, because when you've got the headphones on and you're listening to track down that leak that you can't quite find, you're not focused on other things that are around you. So safety first is definitely something that's a very, very important step with any successful leak management program. Okay, now that aside, obviously there's a lot more to it than that, but we wanted to start with the safety first. The next thing is our equipment. Now we obviously going to be doing an ultrasonic leak detection survey, so we need to have our ultrasonic gun ready to go, the right scanning module set to the right frequency, long-range module if we've got leaks a little further away, and perhaps all the other things we need, leak tags, ties, markers, because we want to actually make sure that we can appropriately tag leaks. The other things, obviously, we need to do our equipment preparation, check that the equipment's working correctly, it's recharged, checking the sensitivity of the instrument both before, during, and after. And perhaps the other thing here is also we need to think about what we might be able to do to fix some leaks on the run. Some people that we've been working with for a number of years now, they actually take a bag of of push fittings and that type of thing with them, there's many leaks they can find that can be fixed straight away. So not only have you found the leak, you've actually already started to lock in the savings. Many sites that we deal with in this part of the world, over half their leaks are simple pneumatic push fittings, that sort of thing, tubing, many of which can be fixed on the run. So a little bit of preparation and having a selection of fittings and that type of thing can also mean that you can actually lock in savings straight away. Okay, well the next point is perhaps one of the most important points of a successful leak management program, and that is actually planning the survey. And what we mean when we talk about planning the survey is simply this. It's reviewing the system layout and looking at how we're going to plan and break down the work. So you can start with a blunt blueprint or schematic, or some people will know them as P&IDs or process and instrumentation diagrams, being aware of where the compressors are, all the auxiliary equipment, the pipe work, where all the end users are. And then what we can do is we can break that area down and identify factory zones and sublocations. Now, there's a really good reason for doing this, because what we can do is we can then break down our survey into sensible factory zones and sublocations, so that we can then look at statistics from our survey, but also what we would like to do is make those factory and sublocation areas match up with the existing plant locations used in your CMMS, for example, so that when it comes to entering work orders into the system, it interfaces with your computerized maintenance management system. The other thing, of course, we need to do is to confirm our production schedule. There are some leaks that you need to survey while the plant's running, but then equally there are other areas where we need to focus on where the plant is offline, just for access and safety reasons. And so depending on your facility, we need to be able to plan for that access. Now the reason we focus on separating out the plant into these multiple locations is, for many people, their facility is quite large, and it may not be effective to do your facility in one go. You end up with a survey that might take 2 weeks to complete, and then you might end up with 300, 400, 500 leaks, which actually translate into 300, 400, 500 work orders, which from a maintenance workload point of view can be quite horrendous. And there's certainly past evidence in this corner of the world where leak surveys have been completed, great work's been done, plenty of savings have been identified, but the leak report has been thrown in the bin just out of sheer frustration of the amount of work involved. So identifying the factory zones and sublocations and breaking down the survey into manageable bites can mean the difference between actually getting people on board with actually fixing the leaks and achieving real savings, versus having something that started out as a great idea that just never quite got completed. So planning, very important. The next thing, of course, is personnel planning. People often talk about this being resource allocation. Availability, what resources have you got available? How many people are we going to have do the survey? Have they got the right training and certification? Perhaps here is a little plug for UE with the UE systems with their trainings programs. They are really quite effective and ensures that people are doing the survey correctly and not overestimating the size of leaks and so on. The other thing, of course, is it's very important to focus on the interface between maintenance staff, operations and management. One of the most successful leak management programs we have running here in New Zealand, in fact, is actually where we have both a maintenance staff member and an operator actually conduct the survey together. The great part of that, of course, is the operators are responsible for running the plant and are there at the plant all the time. They then now are involved with identifying and seeing when leaks are, or where the common bad actors are, as people like to say. Incredible benefits can come from engaging plant operators in the survey. If you're a maintenance person sitting here today hearing this, I'd strongly encourage you to think about how you can engage with some of your plant operators in this process, getting them involved and seeing the benefits of being involved with the survey. Obviously also interfacing with the management, keeping them up to date with the performance and the results, sharing the good news, the savings, getting them on board to support the program. Okay, the next thing is, with personal planning is we need to manage workload. I've already mentioned workload once already today, and you'll perhaps hear me mention it several more times. I cannot emphasize enough how important this is as part of the planning for not just the survey, but managing your leaks as a program. The first thing is we need to look at the identification of the leaks, but then we need to remember that we've also got the remedial action points. Are we going to just find and tag the leak? Are we going to find, tag, and fix the leak? I.e., are we going to fix the leaks internally? Is it something we're going to outsource? Okay, or are we going to have a find, tag, fix, and recheck? And these are the different strategies that differentiate between a leak detection program, or just a leak survey program, and what we refer to as a leak management program. We want to actually manage the process and be in charge of the decision-making process to determine how much work is actually going to provide a valuable ROI, or return on investment, for the company. And this is where we don't want to just focus on finding and tagging the leaks, but we want to fix and recheck, confirm that the leaks have been fixed. Okay, now for some of you it might be most effective to do all of this in-house, and for others it might be something that ends up being outsourced either fully or partly. But the important thing to think about in all of this is the scheduling. Okay, how often are we going to do a survey? Are we going to actually put triggers or automated work orders as part of the CMMS, PM route, that sort of thing? Are we going to just survey small parts of the plant as opposed to the entire plant? So we're going to do an area-by-area survey. One of the sites here in New Zealand that we've been working with for a number of years with their successful leak management program is they actually have their site broken up into 6 zones or areas, and the guys and the maintenance crew get an automated work order every month to do one section of the plant, so each section of the plant gets done twice a year. Another site that only has periodic maintenance periods through the year, the leak survey can be planned a month or 2 months in advance of that shutdown period, so anything that needs to be repaired during that maintenance shutdown can be planned, parts ordered, and so forth. So it's about interfacing not just the leak survey, but also with the remedial action to make sure that that can be timed, scheduled, and completed. Okay, the next thing is data management. Any successful leak management program needs to be able to effectively manage the data. So what are we talking about when we talk about data? Well, there's 2 types of data. There's the fixed system data, and this is information about the system. So, for example, your compressor type, if we're talking about compressed air, or it could be any other compressed gas system. It could be the type of supply of your gas, where it's coming from, and so forth. Okay. The compressor control systems, fixed speed or variable capacity systems, whether it's a variable speed compressor, or a variable outlet vane compressor, or a variable inlet vane compressor. This can make a difference. If you're on a fixed speed system where the compressor is loading and unloading, if you reduce your leaks, then you're actually going to increase the unload cycle on the compressor, which means there's going to be an impact on the actual energy savings that you achieve. Whereas if you've got a variable speed system, as you unload that compressor, you're going to realise a greater proportion of the gains as you fix the leaks. Now, does this mean that if you've got a fixed speed compressor, you shouldn't worry about fixing your leaks? Well, of course not. What it does do, though, is you need to bear in mind that when you're estimating your leak savings, you need to discount probably by 20 or 30% what you're projecting as your power saving. Now, of course, what this means is as you develop your leak management program and get on top of your leaks, you may be able to unload an entire compressor, so you might actually recapture more of those savings. Or alternately, it might help you to build the case to get a appropriately sized new compressor to better suit your needs. So the important thing is to not be discouraged by this, but to be aware of what the impact of the type of system you have will have on your true energy saving figures, what you're going to achieve. My philosophy has always been to underpromise and over-deliver, rather than the other way around. The other thing to think about is the system pressure, your electricity costs, which feeds through obviously into the cost of your compressed gas, be it air or any of your other more exotic gases. Annual hours of operation. Okay, now this is an interesting one. If you think about your annual hours of operation, most people think the plant only works 2 shifts, 8 hours a day, 5 days a week, so you think you're only doing 80 hours a week. Now there's 168 hours in a full week, so therefore you're less than 50% of the year you're actually using the facility. Now, of course, this may be the case, but do the compressors get switched off at the end of the shift, or are they left on? So even though the plant is running only half the time, is the compressed air system and therefore the leaks only running half the time? And so there's little things like this that we can be aware of, and perhaps that's one of the first things you can do to really generate some savings is sort of identify this and say, hey, we need to turn those compressors off when we're not using them. The other thing, of course, is the greenhouse gas emissions. What these figures are, it varies from state to state, country to country, depending on your power source. But these numbers are all important if indeed you are starting to track this, and this will become more and more relevant. But this is all of the sort of fixed data that you need to back up your reporting. Then we get into the variable system data. So what we're talking about here is managing the information we're going to collect as we complete our leak survey. Now this information can actually be quite valuable. It does look like a long list there. We've got quite a bit of information, and for many people that have done a traditional leak survey, they may not collect all of this information. But what we want to share with you today is why we would want to collect this information. And why? Well, first of all, we want to look at the leak location. Okay? Which plant is it in, or sub-location category? Are there parts of the plant that are more prone to leaks? Because these are the parts of the plant that we may need to target more regularly, or perhaps actually build the business case to change the hardware or the systems that we use. Perhaps we're using the wrong fittings, the wrong tubing, perhaps the wrong application. But this can be some valuable information that over time, as you complete multiple surveys, you can paint a picture that can justify improving part of your plant. Most people will tell you that no one in management is going to give you money to rebuild your entire system, but if you track where your leaks are occurring, you can identify the worst actors and identify and build quite a justifiable expense. In many cases, the 80-20 rule applies, where 80% of your leaks can be pinpointed to sort of 20% of your problem areas, and it's perhaps addressing those areas where you're going to get the biggest gains. The next thing is the leak characterization, and this is really quite important for making sure that we, A, don't overestimate the saving opportunity, but B, also that we don't underestimate. We want to give a fairly reasonable estimation of what the leak that we've identified, how much it's costing us. Why do we need to do that? Well, with all these things, we need to make sure that we're fixing leaks that make sense to be fixed. I can give you 2 extremes here. One would be a site that has, an 80% leak rate of their compressed air system. Obviously, that's just crazy and unsustainable, and something would need to be done. But equally, if you had a site that had no leaks, but people were spending an incredible amount of time from a maintenance budget point of view fixing every little leak as they found it, clearly that perhaps may not be the most optimum maintenance dollar spend either. And clearly somewhere in between is the optimum happy medium where we're fixing the leaks that make sense to be fixed and making best use of our limited maintenance dollar. And this is why we want to make sure that we're correctly characterizing leaks so we can make informed investment decisions as a maintenance team to fix those leaks that should be fixed. Now, the other thing to think about is as you start out, you'll be looking for the, the biggest leaks. The 80-20 rule again applies. We can have a reasonably high leak threshold to start with because we don't want to overload our maintenance guys. And this is perhaps the human dimension coming in here again. Guys want to see things that where their work is generating real results. So by identifying the big leaks first, they're going to see that that compressor in the corner is unloaded or is completely off now, is not used, and they're going to start to catch the vision of how successful the program can be. And then progressively over time, we can lower that threshold and get the smaller and smaller leaks until we establish what that happy medium is in terms of the minimum leak threshold that we're going to fix. Then, of course, we get down to the last point of fixing the leak. And what are we really talking about here? Well, once again, when we have to make a decision that the leak's got to be fixed, what are the factors that are going to determine what we need? Access. Is it readily accessible, or is it in a tight spot? Does it need special protective equipment, plant access, elevated work platforms, that sort of thing? We like to estimate the time to fix the leak so that we've got an idea of the dollar spend versus the dollar saved. And then, of course, some situations there might be specialist resources required. But these are all very valuable pieces of information that can help us to manage our leak program as opposed to just have a list of leaks that we may or may not want to fix. So that brings us to actually executing the survey. Now, because we've had other webinars on this topic, we're not going to spend any time today going through executing the survey, but we're going to assume that we've done the survey, we've successfully completed it, okay, and that we're going to move on to what we do post the survey. So the question is this: what do we do now that we've collected all of this information? How are we going to lock these savings in and generate the savings and begin to change the way we do things? Well, the first thing is this: we are going to end up with a mountain of paperwork. And so the question is can we avoid it? Now, there'll be some that will say that we can. We can just sort of get out there and fix the leaks and not worry about recording the leaks. We just need to get them fixed. We can generate the savings. We don't need to generate the paperwork. Well, to be fair, we can, but there's a couple of problems with that. If we don't record it, we can't monitor our performance. The other thing, too, is it makes it difficult to ensure that everything gets fixed. We've got our maintenance staff out there that are going to go and fix these leaks, but if we haven't recorded these things down, how do we know that we've actually fixed what we wanted to fix? And so this is quite important. And so the other thing is, obviously, once we do fix those leaks and we know we've fixed them, we can then actually, A, save the money, but B, be able to document how the money was saved. And so this is all quite important. So what we're going to do now is we're going to talk a little bit more in detail about what we need to do. So the first thing we need to do is we need to review the data. So what we're going to look at is we're going to have a whole lot of leaks. Okay, well, how many leaks? Then, of course, the question we have is, well, what's the workload? How much work are we talking about to fix these leaks? How much are those leaks costing us? And then from that, we can generate a headline potential payback. Now, what we tend to do here, for example, is if we know that we've got a survey that's identified, 200 leaks, but we've got an estimated total man-hours to fix of sort of 40 or 50 hours, we can then obviously apply an approximate labour rate, get a total cost in terms of labour, allow an allowance for fittings, and you can get a rough idea of what our potential costs to fix those leaks are, and weigh that up against what we're going to potentially save. What we can do by doing this, of course, is straight off the bat, first up, before we even get stuck into fixing these leaks, management can see straight away the opportunity that we have and also the resources that are required. What we might then have to do at this point, of course, is prioritise the work. We're going to have to determine and review the threshold. If we found, 300 or 400 leaks, we're going to have to prioritise those and focus on just fixing the largest leaks first. The other thing we might be interested in looking at is what maintenance strategies can we employ to optimise the way in which we fix these leaks. By breaking those leaks down into common areas or common faults, we can perhaps focus on doing a particular type of leak. If we've got a lot of fittings, then we can focus on just having a couple of guys go out and just hit all the fitting leaks, for example, where they can just take the bags of fittings with them and away they go. Or perhaps we've got a common fault with a particular type of valve. That might need to be something that needs to be addressed. There may even need to be an RCA, a root cause analysis process be followed. The other thing to think about there is, are there some applications or leaks that are a repair as opposed to replacement? And you can sort of look at what the common themes are and identify how we're going to attack the problem and maximise the results. It's really about being able to work smarter. So what we want to do is use the data we've collected to be able to make informed decisions and to improve the process, rather than it being what we would refer to down here as a scattergun approach of just trying to sort of hit everything, and in the trouble of doing that we can get bogged down in the trenches and we can lose sight of what the bigger overall strategic objectives may well be. Okay, well the next thing is this. We've done all this, we've reviewed the data. The important thing we now need to do is to actually fix the leaks. And I really like that first line up there. No leak survey has ever saved anyone any money. In many cases, a leak survey can be quite expensive. I'm aware of a number of sites in this corner of the world that have paid tens of thousands of dollars for a leak survey. And then through poor management of the process and a lack of proper data recording, the leaks haven't been fixed and not a single dollar has been saved. The worst case scenario, there's a site that spent $80,000 on a leak survey, and probably 80% of those leaks didn't get fixed. You think about that, the amount of money that was spent on top of the leaks that were being wasted. So the important thing here is to remember that we need to make sure we have a system in place whereby the leaks can be fixed. The only way to save money is to repair the leaks. The other thing, of course, is, okay, we get someone to repair the leaks. What are we going to do to make sure that we follow up to ensure that all the repairs have been completed correctly? A wise man once said to me one day that if you give someone an instruction and you fail to follow up, everything you say to that person, every instruction you give thereafter is meaningless. Now you think about that for a minute. If someone asks you to go and do something, and you go away and you do it, and you work tirelessly at it, you give every ounce of energy that you've got, you put into that, you work like mad to get it done, and they never follow up to ask or to check to let you know that you did a good job, how are you going to feel the next time they ask you to do something? Because human nature is that eventually you're going to think, well, why should I bother? And so a very, very important and almost critical aspect of this is making sure we've got the correct follow-up or confirmation procedures in place to confirm that the leaks have been fixed. We need to have a feedback loop, and part of that feedback loop can be to let the guys know, hey, good job, you've saved X amount of kilowatts or Y amount of dollars. That feedback loop is very important, if for nothing else, the self-esteem and enthusiasm of the guys on the shop floor that are doing the work and making this program happen. We often refer to this as the human dimension, and it is so critical that we actually get this part of the program right. In fact, I would go so far as to say the entire success of your leak management program can be determined by this very step. If you can motivate people, keep them motivated, and also reinforce that by reconfirming the savings they've made, you will have people converted to the process of not just finding leaks but actually seeing things through. And this is how this type of program can become a successful business as usual activity.
James, can I interrupt you for a moment here?
Sure.
I have a couple questions here I didn't quite know how to ask us. Do you have any feel for how much area somebody can survey in a given day, about how much work can you actually get done? Meaning
That's a really good question, and it's a difficult one to answer, because the problem you have, of course, is if I turn around and say you can do, 5,000 square feet of plant a day, I mean, you could go to one factory somewhere where that has so much pneumatic equipment crammed in there you're going to barely get through half of it. Yet you could go to another facility that's so spread out that, you might actually be able to do twice that. As a general rule, you're probably going to get through, somewhere between a few thousand and sort of 5,000 to 6,000 or 7,000 square feet of factory a day, perhaps.
Okay.
The problem, of course, is it depends how much equipment you're surveying and how many leaks you find, because, if you're finding and tagging leaks all along the way, obviously that's taking time to stop and so on. It's really something that you need to sort of see how you go with your plant. But my advice would be this. Start out by saying, right, we're going to do this one little area, and then review and stop, instead of trying to take on the entire plant in one go, especially if you're starting out.
I got you. Another question I have here, I had a question here about poly fittings. Is it recommended to change out all the fittings if predicting that the fittings not leaking today will leak tomorrow? Do you have any advice about the type of fittings and things?
Well, that's once again a really good question there, and what we've actually done is, and this is where that whole data management, recording where the leak is, what the type of leak is, and what you can actually do is you can track over time especially the type of fitting that's failing and where. And we actually had a site here in New Zealand where we did this, and we're able to identify about 60% of their leaks with these poly or push-fit fittings. But what was happening, though, in most situations they were okay, but there was one particular part of the plant where the environment was too harsh and they were just eating these things up. And so we were able to then do some tests to identify the correct hardware to put in. But obviously, this is where you can identify that part of the plant that needed different hardware as opposed to replacing everything. The other thing to be careful with the plastic or poly fittings is many times they fail because they've been installed incorrectly. Too tight a radius on the tubing going into them means that the actual body of the fitting is stressed and will crack. So it's really about identifying the common themes, because although in theory it might be a great idea to replace everything, that isn't the best use of your maintenance dollar. So the whole point behind tracking this information is to be able to identify where you're going to get the biggest reward for your maintenance dollar.
I'm also getting a lot of questions about noisy areas. I mean, how difficult is it with welders and plant noise and things like that? Do you have any feeling on that stuff?
Yeah, well, I mean, as with all things, the ultrasonic gun is only going to be able to find a leak which is at least as loud as the background ultrasonic noise. So obviously, if you're in a noisy environment, you're not going to find those small, tiny little leaks. So if you've got an argon or some other exotic gas system where you're looking for the real tiny leaks because they're costing you thousands of dollars, you're going to have to think about the scheduling of that. But otherwise, the benefits of the ultrasound technology are is you can find those leaks in a noisy background. And this is where what we suggest to people is we start with a threshold typically of 40 or 45 dB, and we only start out by tagging leaks above that point. Now, if you've got a site where your leaks are quite bad, you might even actually raise that to 50 or 60 dB, and then over time progressively lower it. And you'll be able to pick up the leaks around the builders and whatnot.
Understand. Sorry, I'll let you continue.
No, that's fine. Okay, so the important thing is obviously we want to fix the leaks. Now, the next thing is, and this is really goes in line with one of those last questions there, we're then in a position where we can analyze the data. And this is what I refer to as the hidden gold mine. These individual leaks collectively tell a story. You know, we can identify those common themes, highlight areas of concern or focus, and in a lot of sites I can tell you those poly fittings that people talk about, yes, they're an area of focus. But what you can find is that it doesn't mean you necessarily need to go to expensive stainless steel sort of swage lock fittings. There's some often intermediate fittings that are much cheaper that will do the job adequately. You know, the other thing we can do is link to process inefficiencies. You know, sometimes there's a functional failure of equipment or reduced plant capacity that we can pick up on, highlight, which you can use to help justify your program. The next thing is sort of looking at the root cause of failures, you know, common causes. I mentioned previously just a minute ago the environment. Perhaps there's sort of a chemical environment or a hot environment, a UV, being outside in the sun. These things can impact on your purchasing decisions. A great thing is, you know, BST versus MPT fittings, or straight versus tapered threaded fittings. That sort of thing, you know, having both in the store, perhaps there's merit in, you know, standardizing to one or the other so we can eliminate the risk of people putting the wrong fitting in the wrong application. You know, there's some merit sometimes in sort of streamlining these processes, also reduces stock levels, that type of thing. Staff training, poor plant design and or installation. The other thing, of course, is perhaps there's some dynamic loading on the system with some sudden spikes that you might not see when you do the survey, but over time you might be able to identify. So this is where, by recording that information and treating it more than just a leak finding exercise, we can actually take our program to the next level and actually begin to actively manage our system, be it compressed air or some other compressed gas. Now this is where the DMS software can be really quite helpful, where we can track our performance, identifying the leaks. And the thing I really like about these reports is it tells us straight off the bat we can track how much of those savings that we've identified we've actually repaired and locked in. And this can be quite valuable, you know, both carbon dioxide, nitrogen and so on. Now this is where we've actually developed additional tools to be able to make leak management programs a little bit more accessible, beyond just the sort of the basic reporting. And we've actually done a lot of work in terms of improving how we can estimate the CFM loss, and this is something, watch this space, with UE. We'll be releasing this all shortly. And so I guess, you know, the software is there to help you to manage this process and to be able to provide you with the reporting tools to be able to report this back to management. Okay, and this is the important point. When it comes to reporting the results, we need to communicate the opportunities. We need to involve all the stakeholders. What sort of information does management want to hear? What sort of information can we provide to the operators? What sort of information can we reply back to maintenance? And the management's a great one. If you think about most managers, they're not going to read past the first page of any report. So the important thing there is being able to capture in a couple of, preferably some nice pretty coloured graphs so they don't have to read any words, but something that can convey the message in literally seconds, where you can get their attention so they can see the opportunities. Operators, helping them to see what parts of the plant they need to be keeping an eye on, identify areas that that may be of interest. The other thing, of course, is they're perhaps your most valuable asset. They'll be able to tell you about where the problem areas are. And together as a team, we like to refer to these as multidisciplinary teams. When maintenance and the operations side work together, they can really have some fantastic results. Okay, so I mean, ultimately the motto there is to give the right people the right information.
James, can I interrupt you again for a minute here? I got a question about a plant that's not allowed to use Teflon tape, and they have questions about other sealants, and it actually got me thinking about on that, as well as, are you running into the other common problems that you see out there? You might give us a little advice, like the poly fittings and maybe lack of this Teflon tape.
Yeah, well, I mean, I guess one of the great things about Teflon tape is, you know, it can cover a multitude of sins, and this really all comes back to, you know, if that's the stipulation that you have to work with, then it's about identifying other ways to achieve a good result, and this is where perhaps you need to work with your suppliers and identify the correct procedures, and this is where you may struggle initially to sort of have an alternative, but if you can start to collect the information from your surveys and whatnot, you can build the case to management to sort of say, hey, look, this is what it's costing us, we need to come up with a solution, and there's perhaps other ways of going about it. Now, depending on your facility, what you need to do, you know, it may be quite challenging. But this is where people that just point blank say, no, you can't do that, ultimately at some point we need to engage them and say, look, we need to find a solution. And sometimes that involves just more than working with just the people on site, might involve working with your suppliers. We've had a facility here in New Zealand where we've done some customized testing for the facility to test different solutions to determine what was going to provide the best long-term solution. So we did some accelerated age testing of various fittings under some specific environmental conditions to identify what the best solution was, both from a performance point of view and from a cost point of view. So it's difficult to sort of get into too many specifics because it depends from plant to plant, but my general advice would be to consider engaging all of the relevant people that can help you to identify the solution, and this is where tracking the data from your leak survey can provide a valuable resource to build a business case to actually look at something like that.
I got another series of questions here about what types of percentage of leaks are discovered. Where do you typically find the biggest savings? I know that I hear from people in the field about misuse of air and stuff for cooling bearings or sensors or things, but what do you find out in the field?
Well, generally speaking, just leaks in the system, they can be anywhere from sort of 20, 30, 40, 50% of your compressed air demand. Artificial demand, or what we call inappropriate use, that can certainly be also quite high depending on the facility, but the challenge you have there, of course, is actually building the case to change the use. And to come up with something different, be it putting in a blower, that sort of thing. Now, typically, if you're using air in a blowing or cleaning application, putting in a low pressure, or it would be considered a high pressure blower, but low pressure compared to compressed air, with some air knives, you typically have a payback well inside sort of a year, if not 6 months. The challenge, of course, especially in today's environment, is getting the business case over the line where people will actually spend the money, capital's tight. But certainly inappropriate use is a big one, air being used to cool bearings, that type of thing. So yes, that's a problem, but to be perfectly honest, probably the single biggest cause of leaks and system waste would be quick connect or push fit fittings, and poor use of pipe connections, that sort of thing, especially the portable compressed air fittings, that type of thing. These quick connect couplers are notoriously bad due to sort of poor maintenance, poor connections, that sort of thing. But equally as bad as many of those are a direct result of incorrect installation, not having a generous enough radius on flexible tubing going into fittings, that type of thing. But fitting leaks typically, in probably 80 or 90% of the plants that I've seen data for, is the #1 cause of leaks by quite some way, probably somewhere between 50 and 60% of the total leaks, if not more.
Perfect.
Yeah.
Thanks. I'll let you get back to it.
Not a problem. We're not too far away from getting to the last couple of slides here. And I guess, you know, each of these questions is really hitting on the next slide here, which is, you know, tracking and reporting the outcomes, not just the energy savings, but also the reliability improvements. So we've got on-product time, mean time between failure, process improvements. You know, being able to address leaks and getting the system running properly can often mean that aside from the energy savings, the plant now runs better. Then obviously the important thing is being able to document the results and being able to track the historical trend. Now this can do two things. One, it can document that you've actually locked in the savings, which can be great from your business case point of view and building the trust with management to fund the next program that you put up, but also equally to be able to identify those historical trends that can pinpoint those problem areas in the plant that you need to deal with. Now, as a really good example, there was a local site here in New Zealand that had quite a successful leak management program. We'd identified over $80,000 in leaks. They got fixed. As a result, they actually turned off completely a 250 kilowatt compressor. Now the upshot of that, of course, was not only did they save the energy, they saved them annual maintenance costs on that compressor. Then they were able to reallocate that compressor to another site down the road within the organisation that needed it. So they were able to reallocate the capital. So there was also a capital saving. Now what happened as a result of that, the plant manager then came back and said, well, fantastic, good job, guys. Here's $80,000 to put back into the system to improve it. Now, of course, the problem was $80,000 wasn't going to replace their air distribution system. But what they were able to do was they were able to pinpoint one particular area which was their by far worst offender. It was their worst actor. He was quite a bad actor. And what they were able to do was they were able to put down straight away to the manager, said, this is the part of the plant we want to redo. They hard-lined the majority of the plant there, got rid of quite a few fittings and other problems in that particular area. And see, the point, of course, here was the manager didn't give them a blank check for $80,000 to spend on whatever they wanted. They still needed to justify the work. Now, because they tracked the data and track the information, they were able to straight away put in front of the manager the justification for spending that money. So he was able to sign off it with confidence, and the work was able to be done, so they were able to target a particular part of the plant that was their worst offender. And what that enabled them to do, of course, was to permanently lock in those savings by replacing the causes of those ongoing leaks. The next thing, of course, is we need to plan your survey, the next survey, because once we've done the first survey, we then need to get the planning in place so that we've got a formal strategy of when, where, what's the scope, how often, what's the frequency, how are we going to trace this through our computerized maintenance management system, what work orders have we got in place. Are we going to, as we started out earlier, are we going to do just area by area on a monthly basis, or are we going to do the whole plant at once before the maintenance shutdown period? Okay, the key point here is when we go to do our next leak survey, we don't want to find any old leaks. We want to aim to lower the leak threshold over time. We want to identify the repeat offenders. We want to address locations, hardware, are there valves or fittings, that Teflon tape as an example. Are there things that we can identify that we need to address? Are there personnel? Are there certain parts of the plant that aren't being maintained as well as they should be? Is there parts of the plant that are doing exceptionally well? Are there people that we need to recognise and acknowledge they're doing a great job and get them to team up with the guys that are struggling, to help everyone's performance improve? These are really the steps to make sure that our leak management program is a successful ongoing program. And that actually concludes the presentation.
Yeah, I'll take it back from you here if you want, James. Give me just a second.
I'm sorry, I've missed that last slide there, Gary. Ultimately, that just feeds into continually improving our strategy, okay, customising our leak survey strategy, reviewing personnel training and engaging management, okay, consider the role of multidisciplinary teams, getting the operators involved. These are all the things to sort of on an ongoing basis, review the status of the program and always work to continually improve it.
Perfect. All right, let me take it back from you, James. Thank you very much. It's always great to have you, James. So the other thing that we want to do is come back to us at UE Systems anytime you have a chance. These webinars, we store tutorials on different topics on our website. We have lots of applications, lots of information up at uesystems.com. We can help you in your compressed air systems, steams, electrical, or bearings. We'll continue to do these. If you have topics that you would like us to cover in the future, let us know. We'll do our best. We offer training courses all over the place on compressed air, on steam traps, level 1 and level 2 certification courses. Coming up this May, we're having a users conference, Ultrasound World, down in Florida. It's a great place to come hear some of the people talk about how they got programs started up in their plants and how they made them successful. It truly is tremendous. Our next webinar will be coming soon. I'll keep everybody posted, so stay tuned, and we'll pick another exciting topic for you. James, I just can't thank you enough for getting up early in the morning and going into work way above the call of duty and joining us today, and maybe we can get you to do one on another topic, maybe variable speed bearings or something like that in the near future. So,
it'd be my pleasure.
Thanks, James. With that, any information, there's our contact details at uesystems.com. You can email us at info@uesystems, our toll-free number, local number, of course. Anything we help you with, please let us know. And with that, that's going to conclude our presentation for today. We really appreciate you taking out the time of your busy schedule. Talk to you all soon.